about sum and difference formulas. There are 4 sum and difference formulas for the sine and cosine. Obviously, a sum and difference formula for the cosine, a sum and difference formula for the sine. Now, the purpose of this, the sum and difference formulas, is to find the exact value of sine and cosine angles other than the ones we found before by drawing the pictures. So, for example, finding the exact value of cosine 15. Well, before we couldn't do that because drawing a triangle, the reference angle of 15, we have no idea what that triangle would look like. But with these formulas, we can figure out 2 of the values that we do know that would either add or subtract to 15. In this case, subtract to 15 would be 60 minus 45. And since it's cosine, we're going to figure out what the cosine of 60 minus 45 is. So we take that 15 and we make it into 60 minus 45. So we use the formula right here for cosine x minus y, and that formula, I'll write it down here, of cosine x minus y is you take the cosine of x times the cosine of y and add that to the sine of x times the sine of y. So if I go cosine 60 minus 45, then my x is 60 and my y is 45. So I just fill that in. So then the cosine of 60, and I can figure that out, is the square root of the cosine of 60 is 1/2, and the cosine of 45 is the square root of 2 over 2. The sine of 60 is the square root of 3 over 2, and the sine of 45 is the square root of 2 over 2. And if you don't know that, you could always draw the triangles and figure that out. And then when you multiply here, you get the square root of 2 over 4 plus the square root of 6 over 4. And when you combine, because over a common denominator, you get the square root of 2 plus the square root of 6 over 4. If we want to do another one, like finding the sine of 105, we could use sine 60 plus 45. Well, remember, when you add the sum formula for sine, if you go back up here, it's the sine of x cosine y plus cosine x sine y. So it basically would be sine 60 cosine 45 plus cosine 60 sine 45. So the sine of 60 is the square root of 3 over 2. Cosine 45 is square root of 2 over 2. Cosine 60 is 1/2. Sine 45 is the square root of 2 over 2. So when you multiply again, you get the square root of 6 over 4 plus the square root of 2 over 4. And when you add, you get the square root of 6 plus the square root of 2 over 4. Yes, it is the same answer as the cosine of 15, and that may happen on occasion where the answers would be the same. Now you can also use the sum and difference formulas to obtain an exact value by working backwards. So I look at this statement here. It says cosine 80 cosine 20 plus sine 80 sine 20. And I'm like, well, I don't know what the cosine 80 and cosine 20, so I can't fill that in. But I do know that if it's cosine of an angle, cosine of another angle, plus sine x sine y, that is the same as saying cosine of 80 minus 20, cosine of x minus y. Well, what is 80 minus 20? That is the cosine of 60. And the cosine of 60 is 1/2. And if I didn't know what that was, I could draw the picture. The 60 degrees, I know this is square root of 3, 2, 1, so that's how I know it's 1/2. Same thing here. Cosine 70, cosine 40, plus sine 70, sine 40. I know, looking at the formula, that when it's cosine, cosine, sine, sine, and it's adding, that it's x minus y, so I subtract. So I get cosine 70 minus 40, which is cosine 30. And then cosine of 30 is the square root of 3 over 2. The last thing that you can do with these formulas is you can use them to verify identities just like we've been doing. So cosine x minus y, if you remember going back up here, cosine x minus y is cosine x cosine y plus sine x sine y. So you can make it cosine x cosine y plus sine x sine y, sorry, we had a little technical difficulties, over sine x cosine y. Remember, one of the techniques is we can split up a fraction into two separate ones if we're adding, so we can make it then we can cancel what they have in common. We'll notice the cosine y's cancel and the sine x's. So I'm left with cosine over sine, which is the cotangent. And I'm left with sine over cosine, which is the tangent. So notice I have cotangent x plus tangent y. Let's try another one. So the same formula, cosine x minus y, so that's cosine x cosine y plus sine x sine y over cosine x cosine y. Split it up, so you have cosine x cosine y over cosine x cosine y plus sine x sine y over cosine x cosine y. Then notice you cancel the like terms, so you cancel everything out, so there's a 1. Now here you can't cancel anything out, but notice you have sine x over cosine x, so that's the tangent. And you have sine y over cosine y, so that's tangent, but it's y. So that's where you get 1 plus the tangent x plus over the 1 plus tangent x times tangent y. Alright, that concludes our video. Make sure you keep this list that you just got of new formulas handy, because they go pretty much with the other ones. Alright, if you have any questions, I'll feel free to answer them in class. Hope you have a good evening. Thanks.